Okay, so what we're going to do is we're going to go very carefully through the steps for solving a system of nonlinear equations using a graphing calculator. And using a graphing calculator to solve a system of equations is something that we've done before when we were dealing with just two lines. We graph the two lines, we see where they meet, ta-da, and we found our system of equation solution. Now, nonlinear means not lines. So we might be doing a parabola and a line. So one of them could be linear. Or we could be doing a parabola and a circle. Not the prettiest circle I know, but the point is you could find out where any two equations meet, or a circle and a line, or two circles. No matter what you're doing, if you're trying to find a solution to your system, no matter what type of shape your system consists of, no matter what type of equation, it's still always where they meet. That's where you find solutions, is where they meet. Okay, so we're going to get rid of this, and we are going to do first a parabola and a line. So let me finish erasing. And the parabola I have chosen is, that's y plus 3 equals x squared minus 2x. Okay, the reason you know that this is a parabola is because the y is not squared and the x is squared. Remember that the parent function for a parabola is actually y equals x squared. So if you have anything with a y that is not squared and an x that is squared, you're looking at a parabola. Okay, so then my other equation, it's not a system, remember, if you don't have more than one equation. My other equation is going to be x minus 3y equals negative 6. Okay, so one of these is a parabola, the first one, and the second one is, think about it, it's a linear equation, it's a line. We know it's linear because the x and the y are both not squared. Okay, so I'm going to solve this system of equations using a graphing calculator, which means I'm going to find out where these two equations overlap, where they meet, where they intersect. All points that they have in common. That's what I'm looking for. First step is to put them in y equals form. Okay? The reason for this step is because that's the way our calculator knows how to deal with this. Most graphing calculators graph functions only, and they have to be in y equals, they have to be solved for y. They have to be y equals something to be able to put it into the calculator. So that's what I'm going to do, solve for y, and I have y equals x squared minus 2x minus 3. So here's the first equation solved for y. The second equation solved for y, I'm going to move my x, I started to add x to both sides, but I don't need to add x to both sides. I need to subtract x from both sides. So I subtract x from both sides. That gives me negative 3y equals negative 6 minus x. Then I'm going to divide both sides by negative 3. And this gives me y equals positive 2 plus x over 3, or we can rewrite that x over 3 as 1/3 times x. It means the same thing. So I'm going to write x over 3 as 1/3 times x. Really doesn't matter. For this, all that matters is that you have y alone on one side. It doesn't matter if the right-hand side is simplified, if it's a huge mess, nothing matters about that. What matters is that y is alone on the left-hand side. So now I'm going to go to my graphing calculator and put this in. So I open my graphing calculator. Ta-da, there it is. And I'm on the home screen right now. So I need to go to where I put in graphs. The equations to be graphs go in y equals. So I'm going to press y equals. You'll notice it all says y equals. It doesn't say x equals. Most graphing calculators do not give you the option of graphing x equals or vertical lines because they only let you graph functions. All right, so the first one, when we put it in y equals form, right here, y equals, whoops, right here is y equals x squared minus 2x minus 3. So I'm going to put that in y1. X squared minus 2x minus 3. Okay, that's in my y sub 1. Now for y sub 2, I'm using this other equation. That's the y equals 2 plus 1/3 x, or x over 3. It actually might be easier to put it in as x over 3. So 2 plus, and I'm going to use parentheses to make sure it understands that only the x is divided by the 3. You always have to make sure. You always have to stop and make sure that your calculator is understanding you correctly. Meaning, you have to put it in carefully. You have to input exactly how you want the calculator to understand your equation. Very often people say, oh, this is what the calculator gave me, but how is that the wrong answer? Well, it's because you asked the calculator the wrong question to begin with. You have to make sure that you ask it correctly to do what you want it to do. So now I'm ready to graph. So I'm going to go to the graphing window. But first, I like to start on my home, what I think of as my home screen, the standard viewing window for the graph. Okay, and this is going to involve starting at zoom. I'm going to press zoom, and then I'm going to press 6. That's the standard graph window. So zoom 6. And very often zoom 6 is this perfect window for looking at what I need to look at. Sometimes it's not, then I need to move around a little bit. But here I can see exactly what I need to see. I can see that the parabola and the line do intersect each other. They intersect each other in 2 places. They intersect each other right here and again right over here. So I have 2 points I need to find. Now here comes the process that we do every single time we're looking for the points in the calculator. I'm going to hit second, this button right here, and then trace, because I'm going to Calc, and then I'm going to hit number 5 to choose the 5th option. So second, trace, the 5th option comes from pressing number 5, because I want the intersection of 2 things. Now please notice, thinking back on your y equals screen, or you can look at it right here, we only have 2 things. So the first 2 questions the calculator asks you are designed to figure out which 2 things do you want to find the intersection of. If you only have 2 things graphed, y1 and y2, then for first curve and second curve, we can just press enter and look up in the left-hand side of your screen, your upper left side of your screen. It will choose y1 first. Now you say enter. And now it's on y2. And I say, yep, that's the other thing I want to find the intersection of. I want to find out where those 2 things meet. Now for the guess, this is important in this particular case because my 2 objects, my 2 equations, the parabola and the line, intersect 2 places. So I don't want to just find one of those points. I want to find both of those points. So first I'm going to say, let's find the one over here on the left. And I'm going to take the arrow buttons and I'm going to move this. Notice it says guess on the screen. So this is all when it says guess. I'm moving over to where it looks like they meet. You do not have to be exactly right on top of the place. You want to just be close to where it looks like your point of intersection is. And then press enter. And it did find me my point of intersection. So the first place that my parabola and my line meet is at x equals negative 1.3. I'm going to go to the hundredths, so that's 1.36, negative 1.36. And y equals 1.55. So that's a point. So one solution here is negative 1.36, 1.55. That's what I learned from the graph. And that arrow doesn't necessarily need to be there because that point is a solution of both of these equations together, not just one or the other. Notice I type plural solutions because looking at my graph, there's another place where my parabola and my line intersect. It's right over here. So I'm going to go back through the exact same process to find this point. So that process consists of doing second, then trace or calc. Oops, hang on a second. There we go. And the fifth option on the menu. And then again, we only have two things to look at here, so I'm just going to press enter, enter, while it asks which two things. And then this time for my guess, I'm going to move over here to the other point and then say enter when my cursor is flashing over the right-hand point, the one I want to find. And it says that the intersection over here is at 3.69 for x and 3.23 for y. So that's another solution point. So 3.69 for x and 3.23 for y, and those are my solutions. Because those are the 2 points where the graph shows my two equations overlapping or intersecting.